Hello guys, welcome back. In today's session, we'll be talking about the power and exponents. We'll be actually reviewing them because we already talked about the power and exponents earlier this year. So let's hang on, guys. So we will review this thing and we will go to a rational number, and then we will wrap up. If we can cover a square root today, if not, we will cover square root next session. All right, so we already know that a to the power b is an expression saying that a is multiplied by itself b many times. That will be, the b will be exponents here, exponent, and a is base of the exponent, and this whole expression is called the power expression. Okay, so where a is not 0, and that means a is against 0, a is not equal to 0. If a is 0, then anything will be like, there will be no reason to write it down like a to the power b, because a is 0, so 0 multiplied by itself or any number will be 0. And b can be everything, so that means b can be positive numbers or negative numbers, a fractional number. But when we did talk about the power, we had a b has to be a natural number, as I have mentioned it a little bit later. So b was a natural number, but here I said it's everything. But everything will eliminate this problem and this here, because we did not cover them earlier. In today's session, we'll be covering these two and these kind of problems. So hang tight, guys, here, and we will learn something. Exponent being a fractional number or ratio. 3 to the 9 is also a power expression. 1 to the 3 is also a power expression, but 1 multiplied 3 times by itself is also 1. So we can do something. A cannot be 1 also here. Okay, so a cannot be 1. That means if a is a 1, that will be the power. The power expression is for us to make something easier. Our number system should be easier. For instance, like we said 3 to the 9. We will have to write down that 3 multiplied by itself 9 times. But 1 to the power of any number will give you 1. But the degree of the base, which is 1, should be determined. If it is cubed, the degree will be, let's say for instance, if negative 1 power to the power 3 will give you negative 1. But if negative 1 to the power of 2 will give you plus 1, will give you, because negative times negative is plus. So you just have to know the degree is the odd number. The odd power will keep the degree, and the even power will always give you the positive degree. I'm saying positive numbers. For like, let's say, for example, if you have a negative 1 to the power of 5, that will give you negative 1. If you have negative 1 to the power 6, it will give you 1, because negative 1 is multiplied 6 times, which is an even number in itself. It will give you a positive numbers, because negative time negative is always positive. Okay, this thing we just have to remember that. And that being said, we can move on to our next step, which is we talked about b being a natural number, and now it seems like it's a little bit a restricted condition, because we talked 6 to the power 1/3 and 5 to the power 1/2, which is not a natural number. It's a rational, or it's a ratio of two numbers. So we will discuss this, and we will just eliminate this barrier, and we will move on and learn about them. So in this today's session, we will be just taking out that restriction. We'll be talking b can be a ratio or a fraction, and that will be example. That means b a to the power b we talked about here. So a to the power b. So a is not 0, or we will say a is not even 1. So that being said, b can be everything. So we said b can be everything. We already covered the whole numbers or natural numbers. But b can be half, b can be 1/3, b can be 1/4, any number that you think of it as a ratio, b can be that. So these are all the fractional exponents. The exponents are being fractional. And how can we deal with that? As we will deal with them the same way that we dealt with those numbers being a natural. So there's no discrimination there. We will treat them as we were treating the natural number. So the only difference is we have to, this will involve a little bit math. For example, if we have to multiply this number by the 9 times 9 to the power 1/3 multiplied by 9 times to the power 1/3. So the same exact rule will apply here. Only difference is you just have to multiply the fraction now. And we did talk about the multiplication of fractions, so no sweat there. Okay, same rules of power and exponents apply here. Okay, that mean we had rules if you're gonna multiply or divide the powers, the power expression. So what have to be done? And that's okay. So that will include that will conclude. We covered rational numbers in good details. Now the time asks us to talk about a rational number, and we will go talk about irrational number. The irrational numbers are the number that cannot be expressed as a over b, or cannot be written as a over b, or a ratio of a over a and b. So why is that? Example should be square root of 2, square root of 3, square root of 5, and any number under radical expression is a irrational number or a rational number. Irrational number, okay, and that's why the reason is because square root of 2 is equal to 1.414, and that number keep going on to 1.414 to 1, 3, 5, 6, 2, 3, 7, 3, 0, 9, 5. And square root of 3, for instance, is 1.7320050807568877. So this number, if you had to write down this number by the expression of a over b, that would be like quite impossible because it's not definite. So that's how we use the radical, all the radical expressions to write down these numbers, and because that's not a complete, it doesn't have definite value.